Okay,
Demon computer.
how much power will I need to run 32 LEDs at 6 milliamps in parallel?
Sorry, I don't have any information about that.
Okay, let's do some maths. That's right, I said maths because I'm fancy. Here's the thing. The Arduino, while awesome, can't power 32 or more LEDs. This project is going to be at least 30, but could be as high as 40. We just won't know until we see how bright they are. But if the combined voltage is higher than what the Arduino can handle, we have a problem. And the solution is actually external power. We can run a wall wart of sufficient power output to the string of LEDs and separately to the Arduino from the breadboard and actually to any other component in the build. We just have an in from the wall and then out to all of these things. Confusing matters is that there are two ways to wire these LEDs. One's called series and one's called parallel. Series is where you wire the positive of one LED to the negative of the second, and then the positive of the second LED to the negative of the third, and so on and so forth. There are definitely places where you want to wire in series, but this ain't one of them. The series calculation is to multiply the number of volts a thing needs by the number of them. Stated like a smarty pants, that would be P equals I times E, where P is power in watts, I is current in amps, and E is electromotive force in volts. In our case, 5 volts times each of the 32 LEDs is 160 volts. One time, I was swapping an oven in my new house with the oven from my old house, and for some reason that I'm not going to go learn about right now, there are more than one plug configurations for ovens, but I didn't know that at the time. So I got the wrong one from my local big box ironmongery, so I had to go back, and this time I got the one that looks like the scream face that's screaming instead of the scream face that's giving you the look of disapproval. And when I got home with the new one, I wanted to make sure it was the right one, so I plugged it in, and like a magnet to my hand, the other end suctioned onto me, and the power in my house died, and I sat there looking at the floor for like 5 minutes while my arm was tingly because I almost died. Wiring in parallel is when you wire the positive of all the LEDs together in a chain, then wire all the negative LEDs together in a chain. To find out how much juice we need for that, we can apply a thing called Ohm's law, which is I equals E divided by R, where I is the current in amps, E is the electromotive force in volts, and R is the resistance in ohms. One time in my old house, the landline phone stopped working. And after trying for a while to figure out what the problem was, I climbed in the attic and traced the RJ11 wire around the crawl space. The wires were pulled on somehow and had come loose. Did you know that phone lines have electricity in them? The wire was buried in some insulation that doesn't taste like cotton candy, even though it looks like cotton candy. I touched it with my bare hand and got tingly all over. My little LEDs take 0.3 watts, which is the I in our equation from earlier. The E from our equation is 5 volts. So I equals 0.3 divided by 5, which in this case equals 0.06 amps. Now times 32 LEDs equals 1.92 amps total. But we also need to know the number of watts that the power supply will need. That's an easy one, sort of. In a perfect world, we would just take the 0.3 watts from the LEDs and multiply it by the number I'm powering. 0.3 times 32 equals 9.6 watts. But in a lot of cases, electronic parts don't have that tight of tolerances. Weird, right? Sometimes they can be off by like plus or minus 20%. That could add 1.92 watts to my project at the worst case, but we will measure the LED's actual usage as we go. But we do need to know the worst case we're looking at. So 9.6 watts times 0.20 plus 9.6 equals 11.52 watts. That's the theoretical maximum just for the LED string. Okay, so now that we know what size wall wart we're going to need, I, like every good nerd, am going to take us through the bin of cables. Now, Every self-respecting nerd gets called a hoarder by their wife. My wife. But we're not. Okay? There's good reason for this. So what we're going to do is we're going to go through this bin. And we're just going to really quickly try to find the right size wall wart. And while I do, maybe I'll tell you a little story or something. I don't know. Hey, I was looking for that. I was looking for that. All right, let's put that bad boy aside. Glad we found that one. I'm gonna pull out all the ones that are possibilities, and then I'll look at them with a magnifying glass, because even though I'm 39 and my eyesight is perfect, sometimes when I get tired I can't see things very clearly. My eyesight's perfect. After all that, here are our wall warts. There's probably 3 in there that'll do it. And we're probably good. All right. All right, so major bummer. None of those wall warts were the right one. It appears that I'm going to need some help. So I'm lucky enough to have 3 dads. Weird, right? They all bring cool shit to the table, and it's super cool to have phone-a-friends, like, whenever I need them. Thanks, dads. Each one of you. Really. So I call Electrical Dad, and he introduces me to this thing that I'd never even heard of, called a switching power supply. Its output is 15 watts and at 5 volts and 3 amps. It exceeds all of my requirements. The cool thing about this device is I can run just a regular line cable to it, run power out to my breadboard, and it should power the Arduino and all of the LEDs, as well as like the motion sensor and any of the other things I need to plug into it. It should have a little room to grow as well, which is good news for us. All right, so let's start soldering lights. Here's how I find it best way to solder.
Dad, it's dinner!
Okay, so here is how I like to solder together LEDs.
Hey, can you help me with the PlayStation?
Okay, before we start soldering, I just realized how much wire do I need to put between each of these LEDs? We kind of need to calculate like how big this thing's going to be, because... crap. Okay, so the laser cutter that I have access to has a bed of like 19.3 inches by 10.8 inches. So each section of the laser cutting needs to be smaller than that. Like all the plexiglass needs to be smaller than that. And the backboard itself has to be smaller than 30 by 30 inches, because the CNC machine that I have access to, that's the biggest size that it can do as well. And if I want to stay away from having to use a table saw, I just have to keep it under 30 by 30. So to start to get some of these answers, I contacted a friend of mine who uses a program called Inkscape. And here is our logo here. And what we need to do is just break it apart into its components so that we can find out how big each of the pieces can actually be. And then we can make a mock-up of it. So to start to get these answers, I used a little bit of his help here, and we broke apart this image into its component parts. So we have the arrow part, and we have these arrows here. We've turned them red, but they could be any color. It doesn't really matter right now. This size here we set to be the size of the laser cutter, so that we can kind of say, okay, well, you know, if the full back image was this size, we could, you know, the arrows would be this size and these arrows would be this size and whatnot. This backing plate here is actually the set to 27 by 29 and a half, which is the size of the CNC machine that we can use to cut the whole backing piece. So we maxed this out as high as we could go, and then we can kind of factor out what size parts we can use from there. Again, just using Inkscape. And this guy here is the 12 by 12 inch plexiglass. I used a company that I'd never actually heard of before, but I put in an order for plexiglass with them. They're called E Street Plastics. They had really good prices. Shipping is still kind of a problem because you're shipping heavy plexiglass, but the prices of the plexi was pretty good. So this plexi is actually already at the house here, and we're ready to start kind of getting ready with the mock-up. Now, I like to make mock-ups of everything that I'm working on in cardboard. You can make a craptastic ghetto-ass cardboard version of a backboard, in our case, to full scale. And this is a seriously great way to get a handle on projects. And you can find out the weirdest stuff that you would never have thought of while doing this. So the beauty of it in this particular project is here you can see the holocrons and the crystals can kind of set in their respective places, and you can kind of make sure that all the things fit together. Also, I get to try, use a knife and play with my coloring skills. So, of course, it's a lot of fun. Okay, so no soldering in this one, but that's okay. Every attempt gets us closer, and we've already bitten off a lot of little chunks of this project. In the next video, I'll start soldering, hopefully, and we'll see if this power solution works. But who knows, maybe you will let a little black smoke out of some electronics, or maybe I'll get a new shocking story to tell. No, that's dumb. Okay, take two. Or maybe I'll learn a new hair-raising lesson. No. Stupid. No. Okay, take three. Or maybe I'll die. No. That doesn't even make any sense. The show's called Not Today, Grim.